Welcome to the exciting world of cloud computing. Your ultimate destination is to learn DevOps, cloud and CI/CD solutions. Get ready to level up your skills and dive into the world of innovative technologies. This is Vivek. I'm an AWS certified solution architect professional. Today, we are going to discuss Amazon ECS Amazon Elastic Container Service. AWS ECS, Amazon Elastic Container Service, is a highly scalable and fully managed container orchestration service provided by Amazon Web Services, AWS. It allows you to easily run and manage Docker containers on a cluster of EC2 instances or AWS Fargate, a serverless compute engine for containers. With ECS, you can deploy and manage containerized applications without having to manage the underlying infrastructure. It provides a flexible and scalable platform for deploying microservices and distributed applications, making it easier to build, scale, and maintain containerized applications. Key features and components of AWS ECS include 1. Task definitions. ECS uses task definitions to describe how a container should be deployed, including details such as Docker image, CPU and memory requirements, networking, and container linking. 2. Clusters. A cluster is a logical grouping of EC2 instances or AWS Fargate tasks where containers are scheduled and run. ECS manages the underlying infrastructure for you, allowing you to focus on your applications. 3. Services. ECS services allow you to define and run long-running applications or microservices. They provide automated scaling, load balancing, and high availability for your containers. 4. Scheduling and orchestration. ECS uses a scheduler to determine where to place containers based on resource availability, task requirements, and defined placement strategies. It ensures that the desired number of tasks are running and handles automatic scaling. 5. Integration with AWS services. ECS integrates with other AWS services, such as Elastic Load Balancing, ING, Identity and Access Management, CloudWatch for monitoring, and CloudFormation for infrastructure as code deployment. 6. AWS Fargate. ECS supports AWS Fargate, a serverless compute engine for containers. With Fargate, you can run containers without managing the underlying EC2 instances, enabling a fully serverless container experience. AWS ECS offers several advantages for running containerized applications. 1. Fully managed service. ECS is a fully managed service, which means that AWS handles the underlying infrastructure, including server provisioning, scaling, and patching. This allows you to focus on developing and deploying your applications without worrying about managing the infrastructure. 2. Scalability and elasticity. ECS enables you to easily scale your applications based on demand. You can define scaling policies that automatically add or remove instances or tasks based on CPU utilization or other metrics. This allows your applications to handle varying workloads efficiently and cost-effectively. 3. Integration with AWS services. ECS integrates seamlessly with other AWS services. For example, you can use Elastic Load Balancing to distribute traffic across your containers, AWS Identity and Access Management, ING, for fine-grained access control, and AWS CloudFormation for infrastructure as code deployment. This tight integration simplifies the overall management and integration of your AWS resources. 4. Flexible task scheduling. ECS provides a powerful scheduling mechanism that determines where to place your containers based on resource availability and defined placement strategies. This ensures optimal utilization of resources and allows you to define complex scheduling rules to meet your specific requirements. 5. Compatibility with Docker. ECS is compatible with the Docker container format, allowing you to easily leverage your existing Docker containers or use any container image from Docker Hub or private repositories. This provides flexibility and simplifies the migration of containerized applications to ECS. 6. Multi-as high availability. ECS supports running tasks and services across multiple availability zones, AZs, within an AWS region. This provides high availability and fault tolerance for your applications by distributing tasks across multiple physical locations, reducing the impact of a single point of failure. 7. Cost optimization. ECS offers cost optimization features such as AWS Fargate, which allows you to run containers without managing the underlying EC2 instances. With Fargate, you only pay for the resources consumed by your containers, eliminating the need to provision and manage EC2 instances when using serverless compute for containers. 8. Ecosystem and community support. ECS benefits from being part of the larger AWS ecosystem, which includes a wide range of services and tools for container orchestration, monitoring, logging, and security. Additionally, there is a thriving community and extensive documentation that provides guidance, best practices, and examples for using ECS effectively. Overall, AWS ECS provides a robust and scalable platform for running containerized applications, offering ease of management, flexibility, integration with AWS services, and cost optimization options. AWS ECS is well suited for a variety of use cases involving containerized applications. 1. Microservices architecture. ECS is commonly used for deploying microservices-based architectures. It allows you to break down your application into smaller, loosely coupled services that can be independently developed, deployed, and scaled. ECS provides the necessary infrastructure to manage and scale these services efficiently. 2. Continuous integration and deployment, CI/CD. With ECS, you can automate the deployment of containerized applications as part of a CI/CD pipeline. By integrating ECS with services like AWS Code Pipeline and AWS Code Build, you can achieve a streamlined and automated deployment process, ensuring faster and more reliable software releases. 3. Web applications and API backend. ECS can be used to deploy and scale web applications and API backends. You can run multiple containers behind a load balancer to handle incoming traffic and ensure high availability. ECS offers features like auto-scaling, health checks, and integration with AWS networking services, making it suitable for running highly available and scalable web applications. 4. Batch processing and data processing. ECS is often used for batch processing workloads, such as data processing, data analytics, and data transformation. You can use ECS to scale containers horizontally to process large volumes of data in parallel, making it efficient for processing tasks that require significant compute resources. 5. Containerized workloads with variable resource requirements. ECS is beneficial for applications with variable resource requirements. With its scaling capabilities, you can automatically add or remove containers based on demand, ensuring optimal resource utilization and cost efficiency. This makes ECS suitable for workloads that experience fluctuations in resource requirements. 6. Hybrid and multi-cloud deployments. ECS can be used in hybrid cloud environments, allowing you to run containers both on-premises and in the cloud. ECS supports AWS Outposts, enabling you to seamlessly extend your ECS deployments to your own data centers. Additionally, ECS provides integration with AWS App Mesh, allowing you to connect and manage containers across multiple cloud environments. 7. Dev, test environments. ECS is ideal for creating development and testing environments for containerized applications. You can use ECS to quickly provision and manage isolated environments for different stages of your software development lifecycle, enabling developers to test their code in a containerized environment that closely resembles production. These are just a few examples of how AWS ECS can be used. Its flexibility, scalability, and integration with other AWS services make it suitable for a wide range of containerized application use cases in various industries. Thank you. Please subscribe for more topics.